Hello and welcome back to my channel. Here we are going to solve another past year paper from October-November 2020, and it is going to be pure mathematics 1 and code is 9709, component is 13. So let's start with question number 1. Here's question number 1. First part, A part. Express x square plus 6x plus 5 in the form of x plus a whole square plus b, where a and b are constants. So whenever we need to express in this form, we are going to use the completing square method, and in order to do the completing square method, we require only these two. So it is going to be x plus half of 6 whole square minus the number we got here, square of it, and plus 5, and this is going to be x plus 3 whole square minus 9 plus 5, or x plus 3 whole square minus 4. We only need to be careful with this because we always subtract the square of the number we got by taking the half of the coefficient of x. So here we got a as 3 and b as minus 4. Let's do the b part of it. Here's the b part. The curve with equation y is equal to x square is transformed to the curve with the equation y is equal to x square plus 6x plus 5, and describe fully the transformation or transformations involved. We can see that this from the previous part, y can be this x square plus 6x plus 5 can be written as x plus 3 whole square minus 4. So we can see it is a translation of this x square. So first of all, x square, this square means x plus 3, so translation, and in the translation the vector translation by, first of all, horizontally it is going to be minus 3 and vertically it is going to be minus 4. So that's the translation. Here's the second question. The function f is defined by fx is equal to 2 over x plus 2 whole square for x greater than minus 2. Find the integration. This is improper integration from 1 to infinity fx dx. So first of all, we'll put this at the place of upper limit infinity, we'll put it as b, and then we are going to find the limit b tends to infinity 1 to b fx dx. So first of all, let's calculate this. Limit b tends to infinity, and fx, integration of fx, and we can write this as 2 times x plus 2 whole to the power minus 2. This is going to be 2 times x plus 2 minus 2 plus 1 minus 1, and divide by the same minus 1, and the limit from 1 to b. So again this become limit b tends to infinity and upper limit b, so it become minus 2 upon b plus 2 minus plus, because it is minus already, and lower limit, that is 1, so it become 2 upon 1 plus 2, and we'll solve it once more. It is minus 2 by b plus 2 plus 2 by 3, and when we'll put, now we'll tend this b to infinity, means we are going to replace b by infinity. Once it would be b will tend to infinity, 1 upon 2 upon b by b plus 2 will tends to 0, so this answer become 2 by 3. That's the integration. Let's do the b part. B part, the equation of a curve is such that dy over dx is equal to fx, and this fx is given as 2 over x plus 2 whole square from the previous part. It is given that minus 1 comma minus 1 lies on the curve. Find the equation of curve. So whenever we have dy over dx and we are finding the equation of curve, that is y is equal to fx, we can directly do by taking the integration of the different side, that is f of x dx. So it become integration of this, which is going to be minus 2 times x plus 2 to the power minus 1 plus a constant of integration c. Now as this minus 1 comma minus 1 lies on this curve, so it would be minus 1 is equal to minus 2 upon minus 1 plus 2 plus a constant, it become 1. So from here we will get c is equal to minus plus 2 minus 1, that is 1. So we got equation of curve as y is equal to minus 2 over x plus 2 plus 1. That's the equation of the curve. Here's the next question, question number 3. Solve the equation 3 tan square theta plus 1 is equal to 2 over tan square theta for theta between 0 to 180. So we will solve, we will cross multiply, and we will get 3 times tan square theta whole square plus tan square theta is equal to 2, or we can write it as 3 times tan square theta whole square plus tan square theta minus 2 is equal to 0. Now it is quadratic in tan square theta, so we can use the quadratic formula to get tan square theta. It is minus 1 plus minus b square, that is 1 square, minus 4 times ac, 4 3s are 12, 2s are 24, so plus 24 upon 2a, that is 6. So it is 25. So you got minus 1 plus minus 5 over 6. So tan square theta, since it is squared, it cannot be negative, so we have to take positive value. That means we are going to take plus 5 minus 1, so 4 by 6, 2 by 3, or tan theta would be plus minus root 2 by 3, or we got theta as tan inverse of 2 by 3 with positive, or with the negative tan inverse with negative root 2 by 3. Now we'll calculate these values from the calculator. So the first value theta from here is coming 39.23 degree, and from here we are getting minus 39.23 degree, and we can see the next angle for tan is 180 plus the previous angle. So if we add 180 in this, so it is going to be more than 180. Of course that is not acceptable, but in this we can add 180 to get the next angle, that is going to be 180 plus this minus 39.23, and this value is going to be 140.768 and all. So I'll take 7, in place of 7 I'll write 8, because I want the answer till one decimal place. So the solutions of this become 39.2 degree, sorry 39.2 degree and 140.8 degree. So that's it. Let's do the next question. Question number 4. A curve has equation y is equal to 3x square minus 4x plus 4, and a straight line has equation y is equal to mx plus m minus 1, where m is a constant. Find the set of values of m for which the curve and the line have two distinct points of intersection. So whenever we have to solve for a point of intersection, we are going to equate them. So we will get from here 3x square minus 4x plus 4 is equal to mx plus m minus 1. So let's make a quadratic equation out of it. It will become 3x square minus times 4 plus m times x. I'm taking this thing over here minus m, and I took minus common, so it becomes minus times 4 plus m times x, plus this 4 and this is 5 minus m is equal to 0. Now we require the set of values of m for which the curve has two distinct point of intersection. So we can write for two distinct points, we will calculate b square minus 4ac greater than 0. And here the b square means minus times 4 plus m whole square. It means 4 plus m whole square minus 4 times a is 3 and c is 5 minus m greater than 0, because we require two distinct points. And we will solve it now. 4 plus m whole square become m square. 4 2s are 8m. 4 2s are 8m, not 28. 8m plus 16, and here we get 4 3s are 12, 5s are 60, minus 60 plus 12m greater than 0. Or we will make it as m square plus 20m, and 16 minus 60, it is going to be 44 greater than 0. So it is minus 44. And now we will find the values, and we can see this curve is going to be like that. And if we can find the roots, then the set of values would be this and this, because we require the greater than 0 portion. And we can factorize it as m plus 22, m minus 2. So we can see the roots are going to be minus 22 and 2 here. So the m values would be less than minus 2, and m should be greater than 2. These are the set of values of m for which the curve and the line have two distinct points of intersection. I hope it is clear. Let's do the fifth question. And the fifth question is, in the expansion of a plus bx to the power 7, where a and b are non-zero constants, the coefficients of x, x square and x power 4 are the first, second and third terms respectively of a geometric progression. Find the value of a by b. So now we will use the binomial theorem here. For x we are going to, I will write it as, because it's the seventh power, so the first one is 7c0 and a raised to the power 7 bx to the power 0. Next one is 7c1 a raised to the power 6 and bx to the power 1. And then this is going to give us the coefficient of x. And for the second one, 7c2 a raised to the power 7 minus 2 5 and bx to the power 2, that would give the second square coefficient of x square. Then third one is 7c3 a raised to the power 4 and bx to the power 3, yeah. And for x power 4 we will get it as 7c4 a raised to the power 3 and bx to the power 4. So the first term we'll write first term, because this is, we know that it's the coefficient of x. So from here we will get the coefficient of x, 7c1, that is 7 a raised to the power 6 and b, that is the coefficient of x. Second term is going to be the coefficient of x square. So x square would be, from here 7c2 is 21, we can calculate from the calculator, a raised to the power 5 and b square. And the third term is going to be coefficient of x power 4. Coefficient of x power 4 is this, that is going to be 7c4, which is 35 a cube and b power 4. Now if they are in the geometric progression, it means second. Now since it is given that they are the first, second, third term of geometric progression, it means their ratio would be same, that is common ratio. So it means r from the first two terms, common ratio r from the first two terms, it's going to be 21 upon 7, and here it is a raised to the power 5 b square upon a raised to the power 6 b. 7 3s are 21, this is cancelled and this one power is gone, so we got a by b, 3b by a from here. And from the second and third term we got 35 a raised to the power 3 b power 4 over 21 a power 5 b square. So 7 3 is 25, 1 7 5 is 35. It is a square, and from here also it is b square. So we got from here 5b square upon 3a square, and both are common ratios, so we will solve them again. It means 3b over a should be 5b square over 3a square, and these two got cancelled, these two got cancelled, cross multiply, we got a over b as 5 over 3 3 is a 9. So the value of a by b is 5 over 9. So that's it for this video. We'll discuss the next few questions in the next video. Till then, thank you so much.